Yeah, we're live, 7:02, 7:03-ish, close enough to be right on the dot. It's Friday night. Hopefully everyone's doing well. We're getting ready for the weekend. Maybe you guys are getting your cars ready to go and race, although in a lot of places it's getting cold. It's not too bad here in California. It's, still fairly warm. It's still in the 70s during the day. It's a little colder and stuff at night, but not like it is. I was talking to some people, I don't know, up by the Great Lakes or something. And, it can get really cold up there. They get lots of snow. I remember going back to Buffalo one time to do a story that I was doing for one of the magazines and going back there and them explaining to me how they had run, when they did their slabs, they made sure that it was heated because they get lots of snow all the time and they got to work on the shops and stuff. And they want the shop to be heated. It gets a little bit cold down at West Tech, but there's not usually snow outside, so it's a whole different kind of thing. And I remember doing when I was working for the magazines when I first started my first gig. I was doing freelance stuff for Kip and a couple of people at Turbo Magazine. But when I first started on staff, I was at All Chevy Magazine. I remember them talking to me about you need to do a story about prepping your car for the winter. And I'm like, what do you do to prep your car for the winter? Just like wear a jacket when you go outside or something? Because, in California, we don't do that. We don't normally store our cars for the winter. We just drive them. And for me, driving in the rain is very, very cool. Because I remember when I was young in my Camaro, the people, especially like in late fall when all the leaves had fallen down, everybody rakes their yards up and stuff, and they would all put their leaves out in the gutter because then the street sweepers would come by and pick all that stuff up. But with the big piles of leaves in there, you could back your car into there, especially if you had an open diff, and then see how fast you could get the speedometer up while you're spinning your tire in the leaves. The people that rake the leaves probably didn't like that too much, but that's all alleged. But it's just good fun. So it's snowing where you are, huh, Tim? A couple of things tonight. The thumbnail that I put up is of a 671 to OG 671. That one was from the blower shop. I used the intake manifold and stuff from the guys over at Speedmaster, but the blower was a blower shop. 671 stripped blower and stuff. It was very cool. We used it on a lot of things. I ran it on a big block and a small block, and we ran it on the 540, which got up to near 1,000 horsepower, which I think we could have done with E85, and we spun it a little bit faster. We ran it on the LS, which was very cool because it's kind of the OG look, and if it was sticking out of the hood, and all you could see was basically the blower and the carburetors and everything. You wouldn't really know what it is. You just know. I mean, you know what it is. You know that it's a 671 because sticking out of the hood is very cool. Excuse me. But there are guys, especially guys transitioning from OG small blocks to an LS. It's still carbureted. It still has a big roots blower on it. So it has a lot of the stuff that they grew up with. So that's kind of cool. But in the video that I posted, we also ran nitrous, and not just a little bit of nitrous. We ran a lot of nitrous. So I had a Junkyard 5.3, and then we ended up running what is effectively a 300 shot. We just maxed out the kit. Basically, it was a Zex perimeter plate in this case. And I'm not sure. I mean, we went up to 100 jets. And I think we even tried making a run with no jet in there at all, and it just didn't change anything. We made sure to, heat the bottle up because we've got that cool, Westec has that cool water bath that can, we could get the bottle to 120 degrees if we wanted to. It's not probably recommended, but we usually run it, in the 92, 93, 94. And then, if we have a pressure gauge on it, you could run it from their recommendations, kind of 900. Most guys are going to be probably closer to 1,000 or 1,100 to really get the flow going. But the bottle always seems to work best when the bottle is completely topped off, and then we have it at the right temperature, and then we have it at the right pressure, and the first hit seems to be really good, and then it kind of seems to stabilize for a little bit after that. And especially at lower power levels, like if you're only running a 75 shot or 100 shot, then they seem to work fairly well and they seem to last very long. But when you're doing big hits like this 300 shot, so on the nitrous kit, we don't know because I didn't go and test the things individually, which I would have liked to because it kind of would have been cool. I would have liked to have seen if the the maximum flow rate that we hit was the solenoid flow. We know it wasn't the jet because we could drill out a jet and make that bigger. So we don't know if it's the orifice going into the plate, if it's the line going up from the bottle up to the solenoid, or the plate, the flow of the plate itself. So it'd been cool to kind of figure out which one of those things it is. Like put giant solenoids on it, go, oh, nope, it's not that. Put 2 plates on it and split the flow and see if that does. There's a couple of different ways we could do it, but it was kind of cool because it was not only was it a junkyard motor, but it's a junkyard motor that I didn't even check the ring gap on. And I should have. The other one actually had we did change the ring gap on and never had any problems with that. We ended up breaking this one, not while we were doing this testing, but later on. I think we had a blower or something on it when it finally let go. But who knows? We could have heard it doing these kinds of dumb things, because not only were we trying to max out the nitrous plate, we were also getting pretty saucy on the tune. So we weren't taking a lot of time out, and we were also running it, fairly lean, which is not terrible with the nitrous anyway. The interesting thing is when we did testing recently with the guys at Engine Masters, and we did kind of nitrous tuning, and the episodes might be going up pretty soon, before too long. But it's interesting how, because I got to back up a little bit. I did a video or a show with them where we demonstrated the effect of tuning. So we ran the motor like at 12.5 to 1 and then ran it at like 9 to 1 to show how much power that was worth on an NA motor. The interesting thing is we did that same thing with the nitrous, and we thought, okay, great, we're going to be able to tune a bunch more power out of the nitrous because we put a whole bunch of fuel in it. But the nitrous didn't seem to care that much. It's pretty interesting stuff. And even with the timing didn't seem to make a really big difference. And maybe we were kind of in the sweet spot range. I mean, we didn't want to put 29 degrees in it. I think we were in the 21, 22 range with the 300 shot. So we had taken some out, but not the amount that they suggest, because they suggest, they would suggest about 4 degrees per 100. And I would tend to err on the conservative side when we start adding, like the first 100, we run shots where we've run 100 shots. If you have good octane fuel, we don't take any timing out. But then the next 100, we start thinking, yeah, we should probably take one. And then the next one, we would probably take a little more. So, again, it depends if you have 118 octane, which we run sometimes on some of these things. If you have lots of octane, and the motor wasn't especially impressive. I mean, it was a cammed 5.3. So we weren't running high compression where we would be near kind of the limit of the tune anyway, so that we would be ultra concerned when we're running something like that. And, you could take a plug out or something, and it would be nice if you could just take the plug out, because the plugs are pretty inexpensive to change. But when you knock the electrode off the plug, a lot of times you can knock at least small pieces off the piston too, which is not good. So the nitrous thing was fun though, running all of it, because we normally don't do that. Normally we just put nitrous on to show what it does. So it's a 100 shot or 150 shot. Sometimes on some of the big block stuff, we'll run a 200 or 250 or something like that. And then when I unsuccessfully tried to do the big bang deal, we were trying to run a 500 shot, trying to get to 1,000 horsepower. I still think we will be able to do that. I just need to reconfigure a motor so that we can make that happen. Luckily, the 220 heads that I ran on that 5.3 with the big bang nitrous steel, I would do it differently than running plates on it now, because I think I would do it. I'd do it with foggers, with individual foggers, so that we could get even distribution. Not that that's what caused the problem. I totally caused the problem. The thing was lean and I just stayed in it, and I'm like, yeah, we'll just drive through it. You can't do that. You can do that on a 100 shot, but you can't do that on a 500 shot. So we ran the nitrous, which was cool, and running all of it was cool. And again, when we get a wrecking yard motor, ultimately, if you break that, you're not out a whole bunch of money. So it's not terribly expensive. You just hope it doesn't take out the camshaft that you put in. The rest of it is, the 706 heads and stuff. You can take the springs off of them, and if the cam's still good, take the cam out of the rest of it. You're like, okay, I can just go get another one for the wrecking yard. But after you run them for a while, especially the more that you run them, the more you get attached. I remember feeling that when we did the first big bang motor, we thought it was a 5.3, turned out to be a 4.8. We're running the turbos, and I'm thinking, okay, we're going to break this anytime now. Because obviously back then the internet was telling me, oh, you can only run like 8 pounds and they'll blow up, or 10 pounds. They'll definitely blow up. You'll kick the rods right out of that. You'll blow the crank out of the bottom. You'll do all the things that a lot of the forums and stuff were saying that you would do, that, you know, the motor can't withstand that kind of boost, like the motor knows even what boost is. So we kept running it up, and we're like, okay, 10 pounds, and then, you know, 10, 12, 14, 16, 18, 15, 20, you know, 22, 24. I'm like, why isn't this thing broke? But as we're going up and up and boost and making more and more runs, because we made a lot of runs, because it wasn't just like, okay, and early on when you go from 10 pounds to 12 pounds, that's really easy. That's just changing the boost. But as you go up more and more, we had to make changes to the spring pressure in the wastegates. And if you ever tried to change springs on hot wastegates, it's not fun at all. And so that we can readjust it and get more of a range. And, you know, you have to do tuning. You're like, okay, yeah, the ejectors are maybe a little too small. So now we got to jack the fuel pressure up. And sometimes you know, you get to a point where you need to put more or less plug gap in and stuff. So these tests are not just, okay, we're going to run 5 pounds and then 10 pounds and then 15 pounds and then 20 pounds and 25 pounds. And pretty soon we're just done. And all that happened in 5 runs. That never happens. When I post it and show you guys and show you the 5 runs that are the nice even things, there's lots of other runs in there that didn't work out like that. And there was on this big bang motor. But as we make more and more runs, I'm like, man, this thing is just like, this thing is fantastic. It's like perfectly repeatable. It doesn't seem to care. I don't see any, it's not huffing. I'm not seeing any like blow-bys. I'm blowing smoke out. I like this motor now. Now I don't want to break it. But, you know, you eventually have to, because it is a big bang motor. And I started feeling the same way about this nitrous motor, because we'd run a bunch of hits on it, and the thing just kept going and going. And after you buy it for a few $100s or whatever, you get it running, and then it becomes your baby, and you're like, oh, now this is my motor. Before it was just somebody else's junkyard motor. Now it's my motor, and now, you know, I'm invested here now. So that's what happens to me when we're running these things on the dyno, and I was a little bit sad when the thing broke, but you know, you can go get another one. But there's a moment, you know, we had to take a moment. So after running the nitrous, we ran the 671, which was cool, and we ran that on a 383, and that was a built thing. So it had a stroker crank, and since you're going to do a stroker crank, you do forged rods and forged pistons, and it had all that. Had good heads on it, had a decent camshaft in it, and it made good power. It made like 525 or something NA, so it was a good deal. And then the 671 was easy. It was only like 7.5 pounds or something, and we didn't turn it up any more than that, although you certainly could. I think that same motor did over 1,000 horsepower fairly easily, because we're starting above 500 with a single turbo on it. And, you know, it's not a big deal, because it doesn't take very much boost to get there when you have a good turbo and an air to water and good fuel and stuff on it. And we didn't even run that on E85 when we run the turbo. We just ran it on race gas. E85 would have on this blower thing, I don't think we ran E85 on that either, because we weren't running very much boost. And you have charge cooling from the carburetors going down through the blower, and, you know, and all that works out. And like I said, running at 7 pounds, that blower is pretty happy at 7 pounds at that power level. It's like 750 horsepower. That seems to be like a real sweet spot for that. And then obviously you can turn that up, which we had on some of the other combinations. And then obviously the turbo thing, and that's mostly what we're here to talk about tonight, so you guys can let me know all of the things that I did wrong. I think we have a pretty good list. I ran the 6-liter with a turbo because we wanted to demonstrate what turbos do. And, you know, we kind of know we make a decent 6-liter with, you know, this one had heads and cam in it. It didn't need those heads. We could have done it with 317s at this power level without any problem. I think it had a dormant intake manifold on it. And then I originally, the idea was to compare the S475 versus the S480 that I had. And so, you know, one turbo is bigger than the other, presumably, and then you know, does the bigger turbo make more power? The problem is there's not a big enough difference between those two. It's certainly not in the power range where we were running out, which was I think we made 975 or something like that with the S480 at about 12.5 pounds. But there's a few problems. One of the problems was that both of these, the S475 and the S480, so both of the turbos had T4 hot sides, and and certainly the S475. I'm not as familiar with the S480. It probably is the same thing, but the S475 certainly would be much more common with the T6. We had to, the guys from LJMS got me those twin S475s with T4s specifically so that we could run them as twins. Now that's still near 2,000 horsepower with the turbos on a good motor, because with two of them you have less back pressure and you could get all the compressor side and all that. So we, they work pretty well as twins, and those are the ones that we use on the big bang motors to go to 1540 or whatever, and that was about 29 pounds or so. So there was more, certainly much more left in them, especially if I would have made a better 6-liter to begin with. That one was not making a lot of power. It was in the low 500s, I think. We could certainly put something that's in the mid to higher 500s NA and then add boost to that. But the turbos were not what was holding that motor back. And that's why we did the T4s on that. And the same thing on the S480. The S480 actually belongs to Freiberger, and the guys from LJM supplied that. And they specifically supplied them a T4 hot side for that because it was going to be a single and it was going to go on a 5.3. And I think that he was going to put that in a Bonneville car or something. So right off the bat, the two turbos were not what is normally out there. Like if you're going to go buy a Summit S475 or one of these other S475s, it's almost always going to be a T6. And usually it would be a much bigger one. It would be a T6 with a 1.32 AR, because that's kind of the common size. And if a guy's going to put a T4 on hot side on that S475, he's going to have to spend extra money, which is a reason probably most of them don't do that. So right off the bat, there's obviously an issue with that. The other thing is, we didn't run the turbos up to their limits. So where one bigger turbo is going to do, it's going to be easier for me to show the big difference between a bigger turbo and a smaller turbo. One, if they have a big difference between the potential flow rates. Between the S475 and the S480, let's say that it's 100 horsepower, 150 or even 200 horsepower, whatever that number is. You have to get them up to where you've limited the smaller one, and then now the big one can show how much ever extra power it can produce. I didn't do that in this test, so another strike. The other thing, and the really big thing that I think that made people the maddest the most, was the fact that I ran this with a manual wastegate controller. And I in one sense, I loved what happened, and in the other sense, I wish I would have done it. And doing it both ways would have been the best. So running a manual wastegate controller and not touching the controller, only changing the turbo, tells us something. So if we do that change, and then there's a change in the power, which there definitely was, but there's also a change in the boost curve, that tells us that something changed, because we didn't change the boost. So there's a definite change in the shape of the curve and then the attending power output. But the attending power output was more a function of how much boost there was or wasn't at the bottom end. So what happened is, if you guys haven't seen the video, I'm going to give you a little bit of a spoiler alert here. The SR75 made less power down low and more power at the top. But the boost curve correlates exactly with that. So that's why it did that. But the thing is, where the things cross over, where the boost is the same, essentially the power is the same. Not surprising, given the fact that both of those turbos are easily able to support the power level where the crossover was. And so, again, we needed to run them up much higher, and they needed to both be run with, that way, because I would have liked to have seen that, because that's always good information, and with an electronic wastegate controller. So they could just both go up. We could make sure that I had the same amount of heat in them, and maybe a EGT probe or something would have facilitated that a little bit better. And then have them go up to 10 pounds or 12 pounds or 15 pounds or whatever level I was testing them at, and have them go up and make exactly the same boost. And obviously the attending, same air fuel, same timing, same water temperature, and all that stuff that we normally do on the dyno. That would have been a good test. And also, if we could do that, then just go up to where we're at. Like, okay, first of all, will the S475 make 1,000 horsepower? I always say that it is a 1,000 horsepower turbo, but is it really? And if it's not, is it not on a 6-liter, and then it might be on a 5.3 or a 4.8, because they're smaller, and maybe we're topping out the the hot side of the turbo. I didn't show it in this video, but if you take a look at the specific S475 versus S480 video, you can see all of the back pressures too, because we logged all of the back pressure. And that's interesting. And obviously that correlates exactly with what the turbos are doing. There's a lot more information that we could have gotten out of this had I run at least an electronic wastegate controller and then ran lots more boost. But the idea behind this video was to show the different forms of power adders and what they do and how well they work. And this thing was up, like I said, getting up near 1,000 horsepower, which was fairly easy with that S480. And I think we could have gotten to where we got to with the S475 because the boost just fell off. And I kind of now telling everybody that it is a 1,000 horsepower turbo, which I think it is. And I think we've done getting close to 1,000 horsepower, but with the T6 version. So it'd be interesting to maybe compare that Summit S475 with the big hot side as a T6, because I can run a T6 and a T4 on my same turbo assembly, because I have the 3-inch V-band, and then I have an adapter that goes from that up to a T4 or to a T6. So I could compare those two S475s, and then we could do back pressure testing and see what the maximum is and see where they both kind of top out is, and then get we could get back pressure readings and boost pressure readings and see all that. And so that would kind of be interesting. And then I could tell people that the S475 T4 is not a 1,000 horsepower turbo. It's only a 997 horsepower turbo, or whatever the number turns out to be. The other thing is that if we do get 1,000 horsepower at the flywheel, running it in this idealized condition on the dyno, does that mean that translates directly to what's going to happen when you take it out in the car? It's obviously not going to make 1,000 at the wheels, but it'll make whatever number minus the powertrain losses and the difference between however we ran it on the engine dyno and however it's run in the car dyno. So all of that stuff would be kind of cool. I do like the power adder stuff. I like any day on the dyno because I live for the dyno results. I like seeing the difference in things. But it's a lot more satisfying when we make the same amount of effort to change cylinder heads or put headers on or change the camshaft or whatever, or just bolt a blower on. Because with the camshaft, we might get 50, 60, 70 horsepower on a really good combination, like the Hemi stuff that I'm putting up now, and same thing with the LS stuff. But when you bolt a blower on, it's at least going to be 100, and it's probably going to be somewhere between 100 and 200, and then can be as much as several hundred, or you can double the power output, or in the case of the turbo stuff, you can triple the power output. So the power adders are really can make a huge difference. And of all of those, I would say that the Nitrous has the least potential, and normally guys would be more likely to run smaller shots with that. And then like with a supercharger, you can easily add 100 or 200 or 300 horsepower, and the turbos are the same thing. I think we see that less often with a Nitrous. So if there's a hierarchy, I think that's kind of what it is. I remember running Nitrous on my first time on a Camaro. I ran lots and lots of bottles through my Mustang. I've done lots of testing on I'm doing also a Honda power adder deal too, where we ran Nitrous on lots of B series stuff. So done that a lot. So let me know what you guys like. I mean, I'm sure most of the guys here are probably turbo guys, but it's everybody has a choice, and that's why I like doing different things, because even if something is the least expensive and the most powerful or most effective, most bang for the buck, whatever it is, whatever reason that people use to choose for it, there are lots of other people that choose something else. I got guys that will only run Nitrous because that's what they know, that's what they tune, and it makes a big difference, and they can go out and they know how to win with it. Because some guys are only turbo guys because it makes the most horsepower per pound of boost, and they don't want blowers. Some guys are only blower guys, whatever. That's why I test all of it, because all of it's good. So it's Friday night. Let's see what you guys are doing. You're a supercharger guy. Supercharged 350. Yeah, that makes sense, right? Let's see. I'm also doing a Turbo 32 Coupe. I'm also doing a modular Ford power adder deal, which might go up near the same time as the Honda deal does. Yes, 1,000 is the new 500. Admiral 5.4 intakes is a choice is a lot more limited. Anyone have a suggestion for where to mount my wideband? We mount it a little bit away from the, depends on the length of the tube that we have on the dyno, the length of the exhaust. We don't want to mount it at the end because then the initial reading is bad. Once the flow gets going, it's pretty consistent. But we're, I don't know, maybe a foot away from the exit of the turbo. Jordan, doing a GT5 on my stock bottom end LS. Want to push 10 to 15 pounds. What wastegate do I need? A 45 probably would work. Definitely a 50 or a 60 would work. Sometimes that's just a fitment deal. Somebody had an interesting question that they sent me today about the effect of the hot side of the turbo, which affects back pressure. And their concern actually was the change in EGT. Now, in my opinion, I think we can change EGT more with timing and stuff. You can definitely affect back pressure, obviously, with the hot side. But will we, if we're running, the same air fuel and the same timing, and we have, let's say we have, 4 or 5 pounds more back pressure, how much are we going to affect EGT from that pressure change? I'm working on a 10-to-1 454 with ported peanut port heads. Okay. CFM on ported peanut port heads. I'm thinking you could be in the 245 range or 250. No type R79. Is that what that has that how to read that? S475 in the mail for your 6.0. That's going to be a good match. That's going to work well. James, what episode is up on Engine Masters? I haven't seen it, so I don't know what episode that they did first. We want a power glide, huh? Vern, yeah, that's something that's happening with the 91 that's from California. You can't read plugs the same way because every time we pull them out, they look like they're just sooty and black and rich, but that's not what's happening. It's just deposits from it. That's why we rely more on the air fuel meter. I remember Brian Tooley was out here before they got their dyno and everything, and we were running some stuff, and he wanted to check the plugs. I'm like, okay, well, the air fill shows that it's fine, but we can pull a plug out. We pull the plug out. He goes, man, that thing's way too rich. I said, it's not. It's not too rich. It's actually just right. I said that black, and I only know because we've been through this a bunch of times. That black is not from the thing running because it's black like it's running at 8-to-1. It's terrible. 32 Nomad. I've not tested an LS4 intake yet. I have one that somebody sent me, but I haven't tested it yet. Yeah, that texted block I think is what Mahovich uses, and he makes 1,000,000 horsepower, or not 1,000,000, a bajillion. I think, Big Rich, I think ultimately it's probably less expensive and easier for a guy to put a nitrous kit on than it is to do a turbo. The turbo is more involved because the turbo itself is fairly inexpensive. The turbo itself can be a lot less than a nitrous kit costs, especially if you're buying both of them brand new. But there are a lot of other things that you have to have with the turbo. You have to have all the tubing and clamps and silicone couplers and exhaust and wastegate and exhaust after the turbo and all that stuff. You know, bigger injectors and tuning and stuff. So there are a lot of things that people don't talk about when they're pricing turbo stuff. They're like, yeah, I bought a turbo for $163, like me on YouTube. You know, that's the thumbnail. But there's obviously more to it than that. Just the turbo itself was inexpensive, but there's a lot of other things that go along with it. Yeah, Vern, your problem isn't the how hot the spark is. It's definitely that fuel. We have a million gigawatts on ours, and it's still like that. Yeah, Tim, that's what I was telling him about the drop in EGT. I said you shouldn't be worried about that. Of all of the things that you listed, that's probably lowest on the list. I said I can change EGT a lot by changing the timing, and I don't think the pressure change is going to contribute to that a lot. There you go, Admiral. Overbuild. Go in with an overbuild, and then you're ready. If you want to make 1,000 horsepower, Mike, they will definitely work. Why don't we see nitromethane? You do. A lot of the NA guys are using nitromethane. The skunk guys use it in their Honda motors, and a lot of guys are doing that in those import deals. Andy, Howard's Cam says they're 219, 227, operating range is 1,600 to 5,000. This is on a big block, right? Yeah, if it's a 489, a 219, that might be about right. You can improve that a bit with a really nice head and a short runner intake manifold, but a 219 cam is pretty small for a 489, because I'm thinking that I can go take a look at it and see. I'm going to click you guys off just for a second here. Let me know if you guys can still see me. So I'm going to look up where the peak power was. Dyno results. Big block Chevy. Gen 6 cam. New cam. No, that's not it. There we go. Oh, heck. Dyno results. And big block Chevy 454. So peak power with the 224 cam on a 454 was 5,400. So if it's 53 or 5,400 with a 224 cam on a 454, 5,000 is probably a realistic amount on a 489 or a 496. The wastegate just has to be sized big enough to be able to flow and control the boost. actually most people worry about it. They shouldn't, but they do worry about, oh, well, you know, if I'm making 1,000 horsepower, do I have a big enough wastegate? That's not the problem. When it's making 1,000 horsepower and using all of that exhaust and sending all of that exhaust to the turbo and then sending all of that into the motor, that's okay. You need to be able to control the exhaust when you're trying to run 7 pounds, not when you're trying to run 27 pounds. So the wastegate has to be big enough to bleed all of that off. We run twin 45s on our stuff. On the engine dyno, it seems to be a little bit worse, a little harder to control than it is on the street or on the chassis dyno. Oh, see, if you have better heads, that's going to help with RPM. The AirVar 265s will be good. If you put a single plane on it, you can rev it a little bit farther. Ben, you can, if you have a wideband and reading plugs, you can run a blow-through carbureted deal. Especially if you have, what I would like to see is, and what we do sometimes is we'll take readings on both sides. Normally we'll do most of the tuning with just the air fuel meter on one side. If we're doing an EFI, we'll have the dyno air fuel meter on one side and then usually the Holly or the Fast or whatever on the other side, and look at both of them. Just to we're not comparing them if one is 2 or 3 tenths off from the other one. We're not that concerned about that. What we're concerned off is if one of them is 2 or 3 points. If one of them's 14 to 1 and the other one's 11 or 12 to 1, then we go, okay, well, something's going on. We have a sensor going out, or we have multiple cylinders on one side going out or whatever. We just look for big changes. But yeah, you can certainly do that. If you have a wideband and you're running a blow-through carbureted deal and the thing is in the 11s and it's safe, you can definitely do that with a simple wideband. Rob, what was your top speed in the Honda? 200. The speed that they gave me for the record was 226 point something. I think we went more than 227 before the thing spun. Like 1 mile an hour makes a difference. That's Bonneville stuff. You want to see a 400 ZFM head on a 5.3. I wouldn't be worried about the air or the airflow. I would be worried about the size of the port that you had to do and valve that you had to do to get the thing to flow 400. I don't know that with that bore size, with the available valve size that you could use in a head, if you could get something to flow 400. Turbo 32, I agree. I think he most of the time he probably will not be wanting to run in a 4.8 at 1,000 horsepower. He'd be much happier with smaller turbos that are going to be more responsive. Do you think a 5-inch to a 4-inch downpipe? 4-inch is enough to support a lot of power. I don't know what Dulcich is doing with the 363. Is there a limit to blow through carburetor horsepower? You mean a limit in the flow capacity that the carburetor will support? We've done 12 or 1300 with an 850 from CSU. And then I know that the ones that Mike Miller does that are 16, 1800, 2000, 2500, whatever they are, he uses a Dominator style. Vern, we don't run, very rarely do we ever run 87 or 89. We always run 91 because it's always a performance thing. Sometimes we have on occasion, knowing that the motor is 8 to 1 and it has a big camshaft in it, and let's say it made really big power numbers, we're like, okay, now we want to put 87 in it because we know that it's going to be safe. And we want to see if we can get that number on 87. And normally you can, because there's usually not a big difference between the fuels. So we only do that for bragging rights. We're not tuning it. We do that for bragging rights. So we could say made 1,000 horsepower on 87 or 600 or whatever the number is. But when you can throw in the 87 thing, it's like icing on the cake. Yeah, Elite 38 is kind of small. How old do you think a root's 871 to hold up, hung upside down in a street build? You want to flip the blower upside down? I don't know about the gear oiling on that. I have used some inexpensive wastegates. Am I back? Am I back? Yes. Connection secured. Can you guys still see me? I would run at least a 45. If they have something bigger than that and you can fit something bigger than that, I would run bigger than that. Yeah, there is definitely a lack of availability of all kinds of stuff, not just car parts, of everything. Do the first gen 4.6 have any real problems to look out for? I don't much care for the cylinder heads that are on, more the intake manifold. 86 Shelby GLH just sold for 15,000 at Mecum. Yeah, I'm not an auction guy. What heads are on which 454? If you're talking about the one that I gave the cam RPM on, that was a Gen 6 motor. You want to do an X-pipe exhaust before the turbo? Yeah, the spin was exciting. The half shaft broke. Well, it didn't break. It actually just popped out. So where am I at here? Yeah, the BTR cams are making some big power. Cameron, the video that you watched was a problem with the feed pump on the dyno not being able to supply enough fuel because we were running lots of boost on a blow-through carbureted application, and then you get to a point where the pump doesn't want to support that flow rate at that pressure. Ooh, a 4 exhaust port flathead? I haven't seen that. Richard, build the 4.6, correct. I'm not the guy to do that. I would just go over and talk to Mahovitz, who I was supposed to talk to again today, and he didn't call me because he's building me the plate for the adapter plate for the 2.2. Does anybody know if there are any 2.2 Dodge guys here? Does anybody know how much that motor seems to have like slant to it, like the Slant 6 does? Does anybody know how many degrees that is? Because I want to, when we make the adapter plate, we want to be able to bolt the adapter plate basically so the engine has angle to it relative to the bell housing. So if anybody knows what that angle is it 15 degrees or 18 degrees or something? Rear mounted turbos do work. I've got some videos up on it. Turbo 32, a 96 Cobra, so B-headed deal with a Kenny Bell on it. I think I have some videos up on, because I ran, after I did a bunch of testing on the 03 Cobra stuff and the Sean Highland motors and all of those later, like Navigator headed stuff and the 03 Cobra headed stuff, I went back and borrowed a 4.6, a 98 from Mahovitz, and did a bunch of testing on that. We put cams in. I tried a bunch of different intake manifolds. We ran header, we ran nitrous, and I put a Kenny Bell on it. But I thought that the Kenny Bell that I used was a non-intercooled one, and that kind of limited us. But I think it made pretty good power. Ben, you can, and that's what we were eventually going to do, but you have to have the right regulator to do it. You can regulate the EFI pump down to the carbureted pump level. Elite, you want to upgrade the Gen 2 LT1 cam, but why would you want to do it with stock springs? What root style supercharger? I don't know that I like one the most. I like all of them. Like I really like the cheap M90s that I got from the wrecking yard. Or anything bigger than that, like a 112 or 122. Or I was looking at the other day when I was talking to Tom, who sent me the adapters for the LS to mount a GT500 blower on. So we're going to run that. And he even did an adapter plate to mount it to the high ram, which will take the place of the M90, which is good. And I like those, but then that got me thinking, you know what really needs to go on here, because I have a lower intake manifold for an LS that will accept a 671. So I thought, well, with an adapter plate on that, you can put any blower that you want on there. So I could put a Kenny Bell or a Whipple, but I was thinking a 2650 because I've never run one of those. There's no ability to intercool at 96 to 98. See, that's sad. Andy, I don't think that it does. We've run cams where the lift is higher than where peak flow is. I think that that's a myth. Yeah, Ben, we talked about that you have to have the right regulator for that, and the flow rate of the regulator has to be enough so that you can control the fuel and get an accurate base fuel pressure reading while you're adjusting it while the motor is sitting there idling. Because the problem is the pump flows a ton. It flows enough to support whatever the power is at that high pressure. So that means the bypass has to be able to get rid of all that excess, because the pump's like, hey, we're 1,000 horsepower all the time. We're not RPM dependent. We're like all in all the time. So the regulator has to be able to like get rid of the extra fuel that you're not using while you're just driving around and stuff. Yeah, I wonder why Kenny Bell didn't. Why they maybe because of the B heads, it just didn't package well or something. Will a 3-inch exhaust make any difference if my headers are 2.5? Yes, actually it will, because that's what merge collectors are. Merge collectors neck the exhaust down in the collector and then step it back up. And then so what you want from the exhaust, the first thing that you want is enough exhaust to enhance torque production. So if you put an extension after the collector, you're going to get a bunch more low speed power. It's not going to have a big effect on power at the top. And then you want to have, after that, then you want to have enough flow rate from the exhaust to be able to get all the flow out from whatever power output you're making. You can also do some cool things with, if it's an NA motor, with X pipes and H pipes and stuff that can have some wave tuning. But yeah, that's not a problem. You can run a 3.5 after that, or 3-inch after your 2.5. Do you think an additional small engine that is a bolt-on would be a good version of boost, like bolting an extra 4-cylinder to? I don't understand what you're trying to do. So you're running a cam with stock springs. The problem is that even if the stock springs will handle whatever that valve lift is, like there's a lot of no springs required camshafts available from various people for various engine families. The problem is guys then think, okay, I got a cam in my car, so now I can rev it. Well, the problem was that you didn't have enough spring in it before to rev it. And you can also run into, depending on what the cam is doing, how stable the cam is, you can run into valve float earlier with the new cam, despite the lift being able to fit with the valve spring, because it's not a match for the like harmonics of the valve spring. The other thing that's happened to us before in testing is that where the motor valve floats with the stock cam, which can actually be fairly aggressive in terms of ramp rate, by putting a camshaft in it that has more duration, we've tamed the cam down, and as long as it will fit with the available lift, you can get more RPM from a cam with more duration in it, and without valve float. That was mostly on when Brule did that test. I think those are flat tappet small block Chevys though. Ben, you could run 2 regulators. You could Y the regulators and then Y them and dual feed the rail. H pipe for torque and X pipe for horsepower. I wish life was that easy, but it's unfortunately it's not. Yeah, Turbo 32. I have videos up on the Kenny Bell that we use to upgrade the 03 Cobra deal. That's all, Tim. One thing I know about the 340 springs is they're supposed to be pretty good on the slant 6. To 1500 horse size intercoolers. That should work. All right, Andy, we'll see you, man. Suburbans and Yukons were both available with 6 liters. It wasn't guaranteed. They also came with 5.3s. $836. That seems a lot. Doesn't a higher ratio rocker rob horsepower on heads that don't flow well? No, because you're only looking at, that's not accurate anyway, but you're focusing on the wrong thing. So you're thinking if I put a high ratio rocker on there and then now I'm going to a higher lift that goes beyond where the head flows, you're eliminating most of what's happening there. Forget about what's happening at the top. That doesn't do anything anyway. Even if you put a 700 lift cam in a head that stops flowing at 650, it doesn't all of a sudden flow 0 at 700. It still flows something, but you have to look at what it did to get up to 700 lift and then back down to 0 lift. So it's spending most of its time in a range that's not at the peak anyway. But what you've done is you've added a lot more average airflow, and sometimes that can be beneficial. For the rocker question, I'd be more concerned with valve flow, especially on an LS application. But even on others, whenever we put roller rockers on anything, small block Chevy, small block Ford, LS especially, you run into valve float issues. And so you have to cure that. And that has nothing to do with how much lift it has. Yeah, the Motor Trend thing is fun. The Dulcich is great, and obviously the Brulee is my brother, and Freiburger's great too. They're great. They're sharp guys, and they love what they do, and they're real enthusiasts, which I like, and so it's really cool work with those guys. Aaron, I like the LS2s because they're aluminum. If you're trying to make 1,000,000 horsepower, I would go with an iron block. My first Ford car is the one that I still have. It was a 1988 5-liter Mustang, an LX, which I still have. I'm the original owner. You'd be surprised how much power you can make with 2.5-inch exhaust. I think in the tests, I have an exhaust test up where we did a 2.5 and a 3-inch, and I want to say that it was about 10 horsepower, and I think that this was at about the 600 horsepower level. I have lots and lots of cars that I regret selling. I found a 69 tri-power 427 Corvette that I immediately flipped, only because I had to borrow the money to get it because I didn't have enough money to buy it. So I regret selling that one. I regret selling. I had a 2006 Ford GT for a very short period of time. That's a long story, but I regret selling that because that was a really good car. And now they're worth, they're worth $1 bajillion. I wish I wouldn't have sold my first car, which was the 70.5 Rally Sport, even though it was a base car and a 2-barrel car and stuff. It's still, I would like to have that back. The 260Z, I'm okay with. That was a fun car, but it wasn't that one wasn't. I wasn't too emotionally attached with. I'm sad that the Chevy Sprint Turbo went away. What else? And I still have my 5-liter Mustang. Yeah, aliens are driving the Fox. That's right. Can a 2-degree overlap be supercharged? Yes, without any problem at all. You can. Cheapest way to make power with a Honda 4-cylinder boost. Yeah, 2.5 will be fine at 500 to 550 horsepower. When are 6-bolt heads necessary for reliable horsepower? I don't know. I've never used them on anything. I think the only 6-bolt stuff I've ever had was, I think that the RHS block that I had that we did the big motor with, the 495. I think we ran on that, but we never ran it at a power level that was necessary. And given the fact that we ran 1,500 or more on regular heads and a regular block, I don't know where that number is. I also have that's another one that I have, an early 240 4-speeds of 71. Eggnog in the grocery store. I'm not an eggnog fan, but my family is, though. Ooh, a 68 Shelby GT 500 KR. Yeah, those those are worth money. You have 1.5" primary headers? What are you using that on? Those seem pretty small. The 4.6s take to the different forms of forced induction like everything else. If you take a look at, I have videos up on 2 valves, 3 valves, and 4 valves and Coyotes, and we've run all of the different things on them. We've run NA, we've run, and you'll see when I put the modular forward, although there's lots of stuff already up, we've run turbos and blowers and nitrous and everything on them. They all work good. Ooh, a 69400 GS Skylark. I like that. Well, if you have the ability to do flex fuel, it's kind of cool because then you have basically 2 tunes and it switches between them. And guys that are really good at it, if you have a flex fuel sensor, it will start automatically adjusting and interpolating between the two. So with E85, you have to supply a lot more fuel to have it be the same air fuel as a 91 because it takes a lot more fuel. So you're supplying a whole bunch more. The other thing and the beneficial thing of going from 91 to E85 is then you can also run more timing and make more power ultimately, especially under boost. Cameron, you'd never want to run under boost under cruise, because the problem is that when you're running under boost, typically you run a lot richer. So you actually want to run far to the other side of the scale. You want to run under vacuum, and unfortunately for us, unless you have variable cam timing and some other things going on where you can put a lot of throttle angle in it, which you can't normally do if you have a boosted application. So you're going to run under something that has a lot of vacuum, and then you want to run it really, really lean if you're trying to get good fuel mileage. You were talking to Jason at JT. I know Jason really well. He's a good guy. He said 28 to 30 might be too much ring gap on my Gen 2 LT1 383 with 11.5 to 1. You don't need that much ring gap if it's an NA motor. If it's an NA motor, I wouldn't put that much ring gap in it. I would only put that much ring gap in if you're running boost on that 11.4 to 1 motor. I haven't run every nitromethane on anything. Ooh, a 57 Chevy, 71 Torino Cobra. Cobra Jet, I like those. 68 Camaro, that's a good one. Tradesman, I had a Dodge van too. 85 Ram, 77 Camino. Ooh, a 63 Chevy too. I like those too. Those are cool. Is a wedge head not as conducive as a Hemi? I'm not sure what you mean by conducive. Elite, when we run the Fast or the Holly, we don't run any factory ECUs. In fact, I think that the only time I've ever run factory ECUs is when I ran the Coyote, because we had the controls pack that goes with the factory ECU, so we had to run that. And then I also ran a factory ECU initially when I was running the Honda stuff, because I would tune it with, that's another thing that I can tune with, is the Honda stuff. Brandon, you're not going to see a difference between those two unless you try to go make more power than that between those two blowers. You're you're going to go call out Farm Truck. I like the boat that they did. The cars on Street Outlaws and are serious players. They run pretty fast. Oh, Matt, I'm the wrong guy to ask about that. Like I said, I don't run nitrous on anything. I have zero experience with it. You need an awful lot of spark to make nitro work, and if it doesn't, then obviously with the top fuel cards, they're spraying so much fuel in there, they can hydro the motor. That's less of a problem on a normal deal, but yeah, Fascist, it can cruise under some boost, but I don't know why you would. Yeah, Verna sub 5 second 1/8 mile with like a 4.5 or a 4.4. That's really fast. You want to inject nitromethane into a gas motor? Well, they're, like I said, those NA motors that the guys from Skunk do, they do stroke or K series stuff for their drag car, and they're running nitromethane in them. I do have love for boats. For a long time, Brule had a boat that he drag raced. It was a 489 big block. I think I'm trying to remember how much power it was making. I think it was somewhere near 800. Admiral, we do test brake-specific fuel consumption on the dyno. It's easier to do with a carbureted deal, the way that they have their fuel set up. I did run nitro, I think, back in those old airplanes that we used to run and fly around. Yeah, Ben, if it's been your turbo 350, I'm sure that a lot has been done to it to get it to hold with 1,000 horsepower with a nitrous or 1,000 horsepower power output nitrous motor. But I don't know what that break even point is. Jason Wilson, the 429 heads can be ported. The guys from MPG Heads ported a set for our 460. They were early ones, so they were 69s, or they might have been 68 or 69s. And they ported them, and they know what they're doing. They did a good job. I mean, that ported head is not going to flow what a really good set of aluminum heads does, and they're not going to be aluminum heads. Strange, the G8 will be cool with the L76. There's lots of potential there. You should test how compression affects brake-specific fuel consumption. Yep, plane on a string. Those were Cox model airplanes. I remember crashing the heck out of those. I remember the good guys. We had guys that lived down the street from us, and they could fly them in their backyard, and they would horse fly them, which is what they called, which means that they wrapped up all the string in the little handle, threw most of it, and they stuffed that in their pocket, and then they just held the strings so that the string length could be like 4 or 5 feet, and they could fly it in like really close quarters. But it makes the adjustments a lot touchier, but they were pretty good at it. Have you ever checked base timing and inductive delay? Are you talking about what what we're commanding and what it actually is? I don't know how we would verify that. I know that through the whenever we run something through an MSD, there's about 2 degrees of delay in those. And so when we run, for instance, when we run an LS with a Holley HP, and then like we run it fuel injected, and then if we take that off and run it carbureted, like a lot of times I've run the same intake manifold and we've run it carbureted, fuel injected. And if we put on the Holley ignition controller, and we see this on carbureted stuff with an ignition amplifier too, you lose a couple of degrees in that, if that's what you're talking about. So you want to make a run, Admiral, and then change the static compression and see what the effect is on brake-specific fuel consumption number. You want to see if it improves that. Modified oxygenated fuel has the potential to do that. Ooh, a Corsair, yeah, those are cool. I think the one that I had was a P51, but I didn't have it very long. So a regular fresh LS3 run at 85 and then put together a high comp motor with the same cam. But then you're looking at two different motors. You have to do it on the same motor. Otherwise, you're going to get a change that you might not see. You replied to a question I had about running the stock cam and keeping drivability. What are your thoughts on the sloppy stage 1? I've never run the sloppy stage 1. I can't even tell you what the specs are on that. It would be better. I know right away, whatever it is, if it's between a stock cam and a sloppy stage 2, it would be my choice over a sloppy stage 2 for drivability, certainly, especially for a 4.8. Have you run any of those engines out of the old Cadillacs? I have a Cadillac 500. So if that's what you're talking about, then yes. And I have lots of videos up on the Cadillac 500 because we did a bunch of stuff out with the guys from Cadco. We typically gain power when we run like Q16. I tried some testing with propylene oxide and things like that, but usually the oxygenated fuels will make more power. We see that sometimes with the 100 versus 91, but definitely Q and those kinds of things make more power. A stage 2 is a 228, 230. That's pretty big for a 4.8. Admiral, I don't like to do that. I would never do a back-to-back test relying on data from one day and then from one that's 2 or 3 years later, 10 years later, or whatever it is. If you're going to do a test and you want something as specific as brake-specific fuel consumption, it has to be on the dyno the same day. You're going to want to chase that extra octane with your timing. I haven't seen that. I haven't seen. We see oxygenated fuel make more power, but if I go from when we have let's say we have a 10-to-1 motor and then we run 91 in it, we can put all the timing in it that thing will take because we're running it cold. Then we put 100 in it. We know the 100 will make a little bit more because it's oxygenated and it usually requires a change in the air fuel. Then we put 112 or 114 in it. We don't see any more power when we go with more octane. Even if we try more timing, it doesn't do anything. MX guy, we check the timing and we change it each time when we're out there, initially when we run the motor. So we check to make sure that it's whatever the commanded is. And then we just change that number. Like we'll start off with, okay, 20. Is the timing right reading 20? Yes, it is. And then we'll change it from 20 to 30 and then check it again. Did it go from 20 to 30? So we know that it's doing what we commanded. We do that on almost every motor that we run, just to make sure that it's doing what and especially on a new motor that we put on, or if we start a new file or something with the ECU, we always check that to make sure. And it's way more critical, obviously, on a supercharger or turbocharged combination. We want to make sure that it's doing what it's supposed to be. So we check that ahead of time if that's what you're talking about. Do MSD coils produce more power? I haven't seen that. And given the fact how much power we've made with stock coils, I don't know why you would need to upgrade the coils. Most people that say that you want to upgrade the coils are not running the plug gap that you need to run. Your plug gap for high boost stuff needs to be in the teens. I haven't seen the Dodge Caravan with SRT4. Square bore or spread bore. There's nothing like a spread bore quadrajet for making the noise. So I would go with that if I could flip the air cleaner lid over. Have you ever run a 460? Yeah, I have videos up on that already. They're up. 460s and 557s and I think the other ones were 512s maybe or something. Sorry, in a blow through 85, how much can you run without an intercooler? I don't know the answer to that. There's a lot of things that would go into that to determine what the maximum you could run is. Braden, and yours will be the last question. I've got to get going. So going from NA to boost, I need to change the gap or the plug entirely. Actually, it could be both of those. Typically with boost, you want to run a colder spark plug than you do NA. So if you're running, and this is really important if you're running a factory motor. So if we go to get a 4.8 or a 5.3 for the wrecking yard, it has the factory plug in it. We probably don't want to run boost on that factory plug. I have, but you shouldn't. So you want to go to a colder plug, and then also under boost, you don't want to run 45 thousandths plug gap or 40 or 30. We run 20 or less, so 18 or 19 usually seems to be the number, and you don't lose any power from doing that. So a lot of guys will say, "Oh yeah, you need to have that 45 or 50, to get that good." I don't know, the initiation of the flame kernel, and they go into all of this stuff. And I'm like, look, you've never tested, obviously, because that does nothing. It does nothing to power. Okay, guys, I got to get going. I promised that was going to be my last question, right? Thank you guys all for showing up. It's Friday night. You guys go out, enjoy yourself, be safe. And, if you're out there driving your car around and racing around, do one for Richard. I'll see you guys tomorrow.